do is. But that's a job that's totally unnecessary for a robot to do. There's nothing C-3PO does that a person couldn't already do. And if you've seen the Star Wars series, there's a lot of people who could be doing what C-3PO does, and probably there's a lot of people who are like, there's still slavery in the Star Wars. Shouldn't say still because it's a long, long time ago, but there's slavery in the Star Wars series. So there's people who are doing totally unpaid labor. Why wouldn't they be doing what C-3PO is doing? Why would anyone bother creating this robot? So I think that's the main lesson from that, is that it's not useful to make a robot that only does exactly what the people do, because the people could just do it, and you're just wasting your time making such a robot. Another well-known robot is Bender from Futurama, and if you're not familiar with Bender, Bender was created to be a metal-working robot, and then just decided he doesn't want to work anymore, and he basically just sits around. He sits around and eats and drinks, basically. And I think the lesson from that is, like, the more human we make robots, they actually get worse at their jobs, not better, because there are parts of being a human that aren't that great. So all of that to say, like, we don't need robots that act like people to replace people. We need robots that do things better than people and don't have the negative characteristics of people. So let's talk about some actual robots. If your job is to vacuum, which I think a few people that was their entire job, your job's already gone, because that's what a Roomba does. It vacuums for you. And a Roomba, its entire logic is just to figure out where the walls are and move around everywhere it can between them. It's not that complicated, but it became pretty popular pretty quickly because nobody likes to vacuum. If you can buy something to do that for you, why wouldn't you? So I have a Roomba, and I imagine a lot of you do, because if you have somewhere you need to vacuum, why wouldn't you buy one? And that's where robots start taking our jobs, are the things we don't want to do, which that part probably isn't that relevant, because I enjoy doing my job, and I imagine most of you do. But the other side of that is things we don't want to pay to do. And I imagine whoever your employer is would rather not pay you to do that if they don't have to, because development is pretty expensive. So we should look out for that. Another example of a robot, this isn't in wide production yet, but you're probably aware that Google is working on self-driving cars. Not only Google, but Google has gotten the most attention for this, I think. This is interesting, I think, because driving is, when I talk to people about self-driving cars, most of them say they don't want that. They don't think that this is going to actually happen, because driving is an incredibly complicated job. There's, like, people start talking about, like, what happens if this happens, or how is it going to figure out what to do in this scenario? And that's true. There's a ton of variables involved in driving. But the thing is, people suck at those variables as well. Driving is one of the leading causes of death in developed countries where driving are common. There's over 1 million deaths in America per year related to car crashes, and most of those are caused by human error. So it's not like we've set an incredibly high bar that a robot car actually needs to exceed. It doesn't need to do much to be safer than we are. And there's a huge business benefit to self-driving cars. Like 10% of the US workforce is professional drivers, like commercial drivers. So that's a huge expense that we can replace with robots, basically. So Google's working on this. Uber's working on replacing their entire fleet with self-driving cars. Car2Go is working on this so that you can just get in the car and you don't actually have to drive it. There are rumors, unconfirmed, that Apple is also working on self-driving cars. So there's like a huge financial incentive to do this, a huge we suck at this incentive to do this, and there's a bunch of companies working at it. I have a 3-year-old, and I don't think he'll ever learn to drive. I think we're going to, by the time he's 16, I think we will have self-driving cars. I might be a little optimistic on that, but this is going to come and wipe out a huge swath of our workforce at some point in the near future. So the lesson from that for us as developers, first of all, we're going to get self-driving cars, which is awesome. But second of all, part of the thing that makes, talking to developers about robots taking their job, developers think our jobs are complex, and they are, but that's not enough to prevent a robot from doing your job. If there's enough incentive between economic incentive and just maybe we shouldn't all die in car crashes, when there's enough incentive, it will happen. Someone will figure out how to do it. So even if it's a very complex task that we need the robot to do. Another well-known robot is Watson. Watson, if you're not familiar, was developed by IBM to compete on Jeopardy. That was the original point of why they developed Watson, was to find out if it could win on Jeopardy. And it did win. It played against 2 of the best Jeopardy players and won by a good deal. But the interesting thing about it is how it won. It didn't actually answer questions significantly better than the other players. It won by pressing the buzzer faster, basically. And they even handicapped it. They wouldn't let it automatically press the buzzer. They made it have a physical buzzer presser, thinking that would slow it down a little bit. But it was still, it had no hesitation because it could figure out its answer after it pressed the buzzer, whereas humans won't press it until they know the answer. So it basically won by pressing the buzzer faster. It got a lot of answers wrong, including the Final Jeopardy answer. It also wagered better because it knew it was going to get the Final Jeopardy answer wrong and did a very small wager. And it knew it didn't need to. And after Jeopardy, Watson is actually working now as basically a doctor. Nurses call with cancer patients and ask Watson for advice, basically, and they found that something like 90% of the time, nurses actually follow Watson's advice. So I say he, but it's a robot. But the name is Watson, so I'm going to go with he. He's actually working as a doctor, and this is one thing people have brought up about self-driving cars. What about what happens if a car does get in an accident? Well, what happens if a robot doctor makes a wrong diagnosis? I don't know what the insurance issues are there, but someone's already figured them out. So, so the robots are coming. I think the interesting thing here is the buzzer thing. Robots don't have to be better at humans at the things we're good at. They can be better at us at the things we're bad at, and that's enough to replace us in the jobs where we are good. So later we'll talk about what we aren't good at in our jobs. One more, actually, I think I have 2 more. Another robot that I think is interesting for us to think about is the Turk, or it's also called the Mechanical Turk, but that's confusing now because this is what Amazon named their Mechanical Turk service after. This was a robot that was created way back in 1770, and it toured around Europe playing chess against people, and it played chess against, they didn't really have chess champions at the time, at least that's my understanding. But it played against a lot of smart people. It won a game against Benjamin Franklin, and it won another game against Napoleon. Not chess champions, but well-known smart people. And then later, after it had finished this tour around Europe, it was revealed that it was actually a hoax. It wasn't an automated machine at all. That little box there at the bottom, there was an actual chess expert inside the box who was just operating this sort of puppet playing chess. The interesting thing there is, I think that if you're not aware, IBM made another robot called Deep Blue that actually did play chess on its own and ended up beating chess champions. But the thing is, automation was far enough along way back in 1770 that people believed that that could happen, and then 200 years later, it actually did happen. And this, we'll get into this later, but I think the takeaway there is that when people, like when we're close enough to believable fake robots that people will buy into them, then that's a good sign that we're going to soon get actual robots. And we already have actual robots doing our job. Googlebot is a good example of this. There was a time when web developers spent more of their time doing site search before you could just drop a Google site search into your own site. I frequently have conversations now about whether it's worth doing our own search or whether we should just drop something like Google site search into the site. So that's not my entire job, but that's a part of my job that I don't do as much anymore because there's a robot doing it for me. The lesson there, I think, is that robots can take parts of our jobs and start to devalue what our jobs are. I mean, when I'm not building search interfaces, I'm also not getting paid to build search interfaces. And that's part of why I'm not doing them, because it costs the client money. So robots start to chip away at our jobs before they're going to take the whole job over. So that's the robot side. We start to get a sense of what a robot's going to look like when it takes our job. But before we come up with the reaction to that, we should probably also define what our job is. How would you define your job? Like one word, what's your job? Anyone?
Code.
What?
Code.
Coding? Okay, that's a common answer. Programmer, that's another one.
Problem solving.
That's a little higher up the food chain. So this is what my 3-year-old thinks my job is. When I talk about going to work, he says, "You're going to work?" Like, because this is what people see us doing, is just typing. Or if they're paying slightly closer attention, they see us typing and they see code coming out on the other side. So that first one is, this is great too, because this guy was asked to write code for a news sketch, and that keyboard isn't even connected to the thing that's spitting out the code. He just started a video and it's going crazy. Typing and coding aren't really that different. Those are what people see when they see us working. But that's not actually, I think our job is closer to problem solving. These are the average salaries for typist versus programmer versus developer. Developer's at the top, typist is at the bottom. And what I'm interested in is what that gap is between programmer and developer, because a lot of us think of those as the same thing, but at least in how we look at job titles, those aren't the same thing. They're very different in terms of salary requirements. And I think what the difference is how closer we are, how much more we're talking about the product rather than the way we get there. Developer, or if we're talking about development or problem solving, what we're talking about is the end result of our work. If we're talking about programming, what we're talking about is writing code. Or if we're talking about typing, we're talking about the actual act of pressing the keys. So the further away we get from how we do it and the closer we get to what we're doing, I think the closer we're getting to the actual value we're adding. So I think what a developer's job is to make something. And the something we make is the thing people hire us to do. I say that because if you get hired as a developer and write a bunch of code, but it doesn't actually produce anything of value, you're going to get fired. That is not what your job is. Your job is not to write the code. Your job is to make the code do something useful. And that useful thing is what people are hiring developers to do, which is important because I don't think robots are going to write code. I don't expect robots they're definitely not going to type. No one's going to build a robot that sits at a computer and types, but I also don't think anyone's going to build software that generates code. They're going to build software that generates the products of that code. And that's in large part what we're doing now. We're kind of already building those robots. But you might think like the act of building those products is not something that a robot can do because maybe what you do is too complicated, or maybe it requires too much human knowledge that robots couldn't pick up. They would need advanced artificial intelligence for that. I would remind you that what I said before, complexity is not enough to prevent robots from taking your job, nor is having some sort of human knowledge, because that's probably not what you're getting paid to do. That's useful in your job, but it's not the main product. I love the touch screen example. I mean, there's another, like, when Apple got rid of disk drives, people said a lot of similar stuff. I like Apple as an example of a company that just doesn't care what the industry thinks is going to happen. This is a quote by RIM, which made BlackBerries, well, still makes BlackBerries, but nobody buys them anymore. This is a quote by the CEO of RIM when the iPhone was first released, saying, like, nobody's going to buy those because touchscreen keyboards suck, which is true. Touchscreen keyboards still suck. But that didn't prevent people from buying them. He said those at that peak there in the middle. That was 2007 when the iPhone was released. That's when he said that. And as you can see, BlackBerry's stock has plummeted since then. He got fired after that. I mean, he got fired, I think, in 2012 maybe, like after it was too late to fire him. But the important thing here is that, like, yeah, iPhones and Android touchscreen devices, they still suck at typing, but that's not why people are buying phones. And that may have been why people were buying phones before those devices existed, but what people want isn't necessarily what they're being given, and it's not necessarily what you think they want. So that's also true of our job as developers. It's important that we not get too attached to what we're producing, because that might not be where the real value of our job is. And robots might come in and give people what they actually want and didn't realize that they wanted, much cheaper than what we're giving them. So what are those things that robots could potentially do better than us? Does anyone have any ideas? Okay, layout. That's it. So this is, you might have seen this before. This is how I like to talk about what a client's options are, mainly because it kind of forces them to make decisions. But the saying here is that, like, fast, cheap, or good, pick two. You can have something, you can have a good product and you can get it quickly, but it's going to be really expensive. Or you can have a good product and you can get it cheaply, but it's going to take forever to build. Or you can have a cheap product and you can get it really quickly, but it's going to be crap. Like, yeah. So those are your options with development, basically. Like, you can do one of those. And the interesting thing here is that there's already two of these that robots do better than us. Robots are faster than us, and robots are cheaper than us. So the only thing we have to hang on to is that we build better products than a robot could. Like, a robot can already make a website. You can already automate the creation of a website. Like, if you go on Squarespace or Facebook and make a website, that's a totally automated process. You don't have, there's no developer making that site. So that the only advantage we have right now already is that the sites we're making are better than what you can get on Squarespace or Facebook or any of the 100 sites where you can click a button and you have a website. The only thing we have is that we're making those better. But again, once robots start doing something, they always start doing a little bit more than they were originally doing. Like, Googlebot was originally created to index the web, and then eventually they added on the Google mapping car, and now Google indexes the physical world as well with the same technology, with the same automation technology. And soon they're going to take those maps and put them into cars that will drive themselves, and then that same technology is slowly making its way into more and more. So it's not going to take long for the robots that are faster and cheaper than us to gradually become better than us. And some people are saying this has already happened. This is thegrid.io. Have you all seen this? They like plastered Facebook with ads. So if you're nodding your head, it's probably because you use Facebook. What?
I disabled that.
Yeah. So they plastered Facebook with ads, and their promise is artificial intelligence used to design websites. So you tell it like what you want, what your end goal is. You say, I want a commerce site, and this is what I'm selling, and it makes the whole site for you. And then it supposedly watches how people are using the site and automatically updates your site to make it more effective at your goals. And you should go on their site and watch it. It's like it kind of looks like their video kind of looks like a sci-fi, like it has this sci-fi feel to it. They're going to launch in spring of 2015, which you might have noticed has already passed, and they still haven't launched. But they do have 50,000 subscribers already. They haven't launched, they haven't done anything yet other than talk about what they're going to do, but they have 50,000 subscribers at $100 a year. So they've made $500,000 with nothing. They've so far launched nothing. I think like this might turn out to be bullshit. We'll find out if they actually launch ever. But even if it is bullshit, it's the mechanical Turk of automated web development. And as I said before, like that turned into a real thing. People already believe enough that they can automate web development, and they're willing to buy into that with $500,000. So I think that's a good sign that this is going to happen eventually. I'm a little skeptical it's going to happen on thegrid.io, but it's going to happen at some point. So, yay. Nobody's, I think, initially excited about their job going away. I don't know. I'm a little excited about it, but only because I'm confident I can get another job. But it's not a thing that people are naturally excited about. So our options are to fight against this or to go along with it. And I think our instincts are to fight against it, which is a little ironic for the field we're in. There's a name for people who fight against technology change, and it's a word we use. Well, I guess we don't use it as much because everyone's kind of embraced technology, but it's a word we used to use, which is, I think it's pronounced Luddites. And that's the name for people who are like don't want technology to change. And that's a bad thing now. If you've heard that word, you've heard it used pejoratively. And that's what we would be if we tried to prevent robots from taking our jobs. Luddites are actually, like, where that name comes from is actually a cool story, and I think they're kind of cool. That it's named after someone named Ned Ludd, who either didn't exist or was dead before this movement happened. It's not clear whether he ever existed at all. It's also not clear who the Luddites were. So they were an entirely secretive organization who both like wrote open letters, and like would destroy machinery when textile work was being automated, which I think is like fabrics. So I guess like I don't know a lot about textiles, but mills I think are a thing that makes fabrics. So when that was happening, the people who used to do that manually realized that their jobs were going away, and they started fighting against it. And they would like break the machines, and they would write these letters saying like, the machines suck, they're taking our jobs. And they did this all secretively, and then the British government like rounded up a bunch of people who might have been part of the organization. They weren't really sure, and executed them, and then it went away. It's surprising how that happens when you execute. So there have been several other, like, machines have been replacing people in work since as long as machines have existed, and people generally react against it. And those people are sometimes called Luddites or sometimes not. But the thing is, those people always lose. They never win. Nobody ever prevents technology from changing the world. If there's a reason for technology to exist, it will exist. So we can fight against it, but we're going to lose. So I suggest we bring on the robots. We encourage them and help them replace us. And the reason I suggest that is that's kind of our only option. If we fight against it, our jobs are going to go away, and then we're going to have to find jobs in some completely other industry. If we help it happen, then we're going to reap the benefits of it, and we're going to make the money from the robots rather than losing our jobs from the robots. So let's start doing that. This is going longer than I thought it was, but hopefully I'll have time to talk about this. Is this working? Yeah. This is a great video. I love this. So if you watch this, you can see what's happening is the robot's doing exactly what it was told to do. It's reaching forward, grabbing where the wheel should be, and then turning the wheel, but because there's no wheel there, the robot just falls over. And the whole problem with this is that nobody told the robot that it needs to stand where it needs to stand before it starts this process. All of this to say, robots are incredibly stupid, and so are computers in general. Like, computers are super fast. It's easy to think of computers as smart because we throw so much code at them, but they're just really fast at processing things. But Paul Ford wrote this great article, if you've seen it, called "What is Code?" where I think it's like 18,000 words long, and then they fired the director of Bloomberg the web director of Bloomberg after that. But it's a great article. Anyway, one of the things he says in it towards the beginning of it is that robots are basically just super fancy clocks. Like, all they do is mark the next step. They just move electrons on to the next step. And so everything we've built up on top of that is just moving electrons from 1 to 0. So computers are still pretty dumb, despite all of the code we've thrown at them. And if we want to make it easier for robots to do our jobs, we have to explain what we do, basically. And we're already doing this in a lot of places. There's a lot of formats that we use that are already easily read by robots, and in some cases already actually read by robots. JSON is one of them. This is a package.json file that gets read by NPM, and NPM is sort of a robot that reads this file and figures out what node modules we want, and follows the dependency tree up, does the things that we would do if we just went out on Google and found the GitHub repositories and downloaded these one by one. We don't have to do that work anymore because we have a robot that does it for us, and that robot's able to do that because we have this simple format that tells it how to do that. It tells it where, most of what's relevant here is just that repository line that just tells it this is where you find the repository. There's a lot more you can do with this. Like, that assumes that the repository is on GitHub, which you can do it other ways as well. But anyway, JSON is a format that robots can easily read and figure out what to do with. Another obvious one is robots.txt. This is what we use to tell search bots where they can and can't go on our site. And this is part of the robots.txt from GitHub that tells TwitterBot. I don't know why TwitterBot is crawling GitHub exactly, and why that one. I didn't look at that eCanza repository to figure out why they definitely don't want TwitterBot reading that, but this is what tells TwitterBot where it can and can't go, and other bots. So that's another example of a format that robots can read, and using formats like this make it easier for robots to do more of the type of stuff that we're doing. HTML is another robot-readable language. Your web browser is basically a robot that reads HTML and turns it into a display, which is something we used to do. Like, programmers used to do that work. They used to create visual representations of content more manually, and now we just we put in HTML, I want this to be the title, and your browser figures out, however it wants to, okay, that's the title, I'm going to put it at the top of the window, or I'm going to put it in the tab, or if you have a non-visual browser, I'm going to speak it out loud. HTML is a language that tells a robot browser how to present the information to an end user. YAML's another one, and probably my favorite. And this is my favorite example, too, of this sort of approach. This is an application, or I guess the input of an application created by a joint effort of the Sunlight Foundation, which is like a government transparency organization, and the Electronic Frontier Foundation, which hopefully you know is working for digital rights, basically. And they previously had this thing called Formageddon. Oh, so what they do is they contact Congress, basically, or help their supporters contact Congress and say, hey, we should have net neutrality or something like that. And they previously did this with this giant Ruby app called Formageddon that would it had all of the logic necessary to, so this is hard because Congress doesn't want to be contacted, it turns out. And every member of Congress has, they're required to have some sort of contact form, but they make them totally different and they change them regularly so that it can't be automated. Because they don't want to get a bunch of bulk messages on the same topic and find out that all of their constituents care about something. So they previously did this in a Ruby application, and they would have to change it every week when the members of Congress changed their forms to make it more difficult to contact them. And they stopped doing that because they realized that not only were they dumping a bunch of effort into it, but there's 100 other organizations that are trying to contact Congress, and they were all doing the same thing in their own code base. So even the Formageddon thing is open source, and you can go look at it, and it's kind of a mess of code because they had to update it so frequently, and they just didn't have the time for it. What they're doing now is writing YAML files that describe how to fill out a form. And that's what this is. This is for Diane DeGette, who is my representative and probably many of yours. And this is how to fill out the form on our website. It says where the form can be found, where it's getting posted to, and it says for each, these are the fields that you need to fill in, and this is how we're going to name the things that go in those fields. So the name field, we're going to say name prefix and put that in that, and it has the selectors for them. And this is everything an application needs, or an application or a robot needs to fill out that form. It's also everything a person needs. You can read this and fill out the form. It's totally human readable and easily human writable. And it's way more active. They don't have to maintain this anymore because individuals in each district are maintaining these YAML because they're simple. So this is way more successful than their previous approach to this. I should be going faster. So one more, Gherkin is the syntax used by the BHAT testing framework. And this is the most closest to English because it is basically English. And it goes through and says, given this scenario and this, when I do this, this is what I should expect to happen. And this is how testing works in BHAT. What happened, there's only a few keywords in this, given, and, when, and then. And everything else gets converted to a function that has to figure out what that actually means. So when I is ignored, and press the coffee button becomes the name of a function. And you have to write that function that says press the coffee button. This is a description. This is directly off the BHAT website, and this is a description of basically how to automate a barista's job, which is interesting because that's a thing that's actually happened. This is, I guess, maybe the best example of how we can be making things more useful for robots and people. Basically, every stateless API is also consumed by robots. And if you're writing code that interacts with APIs, you're basically writing those robots to do whatever the API describes. What all of this has in common is that it's declarative programming. It's saying what should be the case, not how to get there. That's the difference between declarative and imperative programming. Imperative programming describes how to do something, and declarative programming says this is a thing. And often that thing is the end result. It talks about what you should be doing, not how you should be doing it. So the first part of helping robots take our jobs is doing more declarative programming. We should be taking more of the work we're doing and defining it in code as what needs to happen before we write the actual execution of that. But that's only the first 90%. I love this quote just because of that last number. That's only the first part of it. The second part is actually making the robot. And I'm not going to explain that part in detail, first of all, because I don't have a ton of time, but also because that's what you're already doing. If you're writing code, most of the code you're writing is explaining how to do things. What I'm suggesting is before you do that, you should define in code what is the thing that needs to be done. Do that first, and then write code that consumes that and makes it happen. And the result of that is the code you're writing that says how to do things gets much smaller, because it's part of what you're doing currently if you're not already taking this approach. If you're not doing declarative first, part of what you're doing is explaining what needs to happen in your imperative code. And I'm suggesting you should stop doing that. Rather than explaining what needs to happen in your imperative code, you should do that in declarative code. And then you can write the code or the robot to do that, and that code can be replaced while the declarative code sticks around. So what before how? The what part is dumb. It's for the robot. The how part is the smart part, where you're actually building the robot as smart as you can. But the more you put into declarative, the less intelligent the robot has to be. This is great for robots. It's also great for people. Defining the end goal of what you're doing in code requires you to clarify it, which doesn't allow you to make assumptions about what you're doing, and often those assumptions are wrong. So it makes our work faster in the end. Declarative also lasts longer. If you haven't noticed, we're still using HTML, and the first website still works. Meanwhile, we've changed our how we build websites and how browsers work 100 times since the first website was made. But that declarative HTML has stood the test of time, whereas all of our other code has been thrown away. So that has the effect of making our work cheaper as well as faster, because we have less to reproduce when we're updating things. And those cheaper and faster are the things that, so this makes it easier for robots to replace this, but it also in some ways makes it harder for robots to replace this, because cheaper and faster are the things that robots are better than us at. So by making our value greater with less cost and less time, robots are going to be less attractive as replacements for developers. So that's all I have. Basically, do declarative first. Totally what Gandhi said. And if anyone, I think we have 10 minutes for questions, if anyone has any. Nobody? You're all ready to?
What's your favorite robot?
Oh, gosh. That's a great question. I should have had a prepared answer for that. I think I like Hal from 2001 Space Odyssey, just because I'm going with he based on the name, but robots don't really have gender. He follows his instructions to the letter, and he's the bad guy in that movie, but really the bad guy is the person who programmed him to do that. That's the lesson I took away from that movie.
In your opinion, how long before robots push out of work?
Yeah, was thinking about that. I intentionally didn't say that because I don't know. I wouldn't. I would put it like. I would put it around where self-driving cars. I think 15 to 20 years maybe. Like, there are still people who do vacuuming. Like Roombas didn't totally replace them. There's still people who work in car factories, even though most of that work is automated now. There's still people running that. So I don't know if the job developer is going to completely go away, but I think it's going to turn into a job that's more and more connecting the automated tools and less writing code from scratch. And we're already heading in that direction. Like more and more of the work we do is connecting APIs and less building things from scratch. Yeah.
Do you think that when this happens that we're going to have a lot more leisure time as human beings, and that the flip side can happen where we're all just kind of like, we don't have any resources to even have leisure time because we have no jobs?
Yeah, so that's the big question, not specific to automating development, but specific to automation in general. Like we already, like I made the joke about like robots can already provide us with food and drink. We still have to pay for that, but I mean, once we have, I'm hopeful it's the former, I think, but I don't know what we need to do to make sure that happens. And we don't have a great track record for using technology for its best purpose. But like, we already have enough automation that we don't need to be working nearly as much as we are, but we're still working a lot. So I guess I would turn the question back around to you and ask you, why are we working as much as we are? I don't know. I mean, it's definitely a huge economic shift. As we don't need to work as much, are we actually going to stop working, or are we just going to do different things? Yeah.
Isn't the question like, will there be more leisure time? Listen, isn't that sort of up to you? Like, are you going to build a robot that's going to make the money for you so you can have the leisure time?
Yeah, I mean, that's another thing. Like, the people who are going to decide that are the people who own the robots. Like, so.
Build the robot.
The interesting thing is like, we've had similar things before. Like, it used to be that everybody in the country worked in agriculture. Now it's like moving towards like service work and like restaurants and stuff like that. So we have these previous things that found us after robots do everything. There's nowhere for anyone to move anymore.
But that's not entirely true. So the economy is manufacturing. I'm probably butchering this, but I took a class on this 12 years ago or something. But it's manufacturing, service, and then the top of it is art. And we could all just do art all the time. And that's kind of where, like, I don't know. I feel like more and more of the development we're doing is just like, hey, look at this cool thing I made, and less like things people actually need. So, yeah.
Going with that, though, do you see robots becoming innovators, or on that art level, does innovation also occur that they can't touch?
I don't know. I'm pretty skeptical of artificial intelligence just because we've been hearing about it for so long and it's not actually arriving. Like, I'm not skeptical of automation, but I mean, there's already robots that create art. Like, there's algorithms that produce decent sounding music. There's a great series on Radiolab about like automation and what it's, or maybe it's not Radiolab, Planet Money, on automation and what it's doing to our economy. And part of what they talk about is there's already automated production of like music and visual art, and it's okay. They're not my favorite band, but they're okay. But that's not like, it's not artificial intelligence really. It's not innovating. It's just taking patterns and creating music out of them, or just randomizing, throwing paint at a canvas, which, I mean, half of the art people produce looks like that to me. So I don't know. I'm skeptical of the innovation side of automation. I'm more worried about just the raw automation side of it.
Have you read this book, A Whole New Mind?
No.
It's basically the same argument that
I hope so. We'll find out. Anyone else? Cool. Thanks, everyone.